Hello there. This is a slideshow of just still pictures of the building process and some shots from the air on my homemade helicopter kit. It's called a Helicycle. Its FAA registration number is November 750 Golf. This is a picture that was taken about halfway through the construction process. Most of the major components are there. The engine's been installed, the fuel tanks, the transmission, most of the wiring harness. So it looks like it's a mess, but it's actually about half done at this point. But you can see there's a lot to it. The heart of the helicopter is this military surplus gas turbine engine. It's called, the manufacturer is Solar. The model number is T62, T32. It has 150 horsepower and it's quite small and extremely reliable. These are military surplus. The kit manufacturer, Eagle, takes these and disassembles them, checks them all out to make sure that they meet the original specifications, and then runs them on a dynamometer to make sure that they're functional and that they're putting out power and operating correctly. So this comes with the kit. It's the heart of the helicopter. And from right to left, of course, at the back is the very large exhaust, and then the silver big can in the middle is the hot section, and then if you go to the screened area, that's the inlet where the air is sucked into the engine. Forward of that is the gear reduction drive. Up on top is the starter motor. And then to the left is the output, which is a 6-ganged pulley. The engine runs at approximately 61,000 RPM, idles at 45,000. And the gear reduction drive drops the RPM of that pulley to around 3,000 RPM. That pulley then, through 6 V-belts, drives another 6-gang pulley, which drives the transmission and the tail rotor. One of the really nice features of the Helicycle kit is this rotor hub assembly. And here you see all of the precision machine parts and bearings that go into the rotor hub. The word that I've heard is this is a copy of the Bell 206 Jet Ranger rotor hub. Apparently the patent expired, and so they were able to simply copy that design, which is a very robust and very reliable design, as you can see from all these parts. This is a beautiful thing. Some of the custom stuff that I did starts with the instrument panel and the interface chassis I built, which you see in the lower left part of the picture. All of my cable harnesses plug into this interface chassis, so I can completely remove the lower instrument panel and the upper instrument panel from the aircraft if I want, and take them out of the helicopter. So everything plugs into that interface chassis, and that's where my battery return and my battery bus are. So all of the avionics and the electrical stuff is powered from those 2 buses, which are fed from batteries in the back of the helicopter. One of the other custom things I did was to design and build this rotor RPM alarm circuit. Those 3 little white chips you see are solid-state 4-amp relays or switches. I used 2 of them to simply illuminate indicators on the instrument panel below my tack. One of them is a low rotor RPM alarm, the other is high rotor for the upper and lower edges of the green band, which is 610 to 620 RPM. The third one causes a very loud screech to come out of a solid state acoustic transducer called a sonalert. That one goes off at 635 RPM, which is the red line. And normally you would never approach that RPM unless you were in an auto rotation. So the idea here is during an auto rotation you're coming down very fast with no engine, or the tail rotor blew off, one or the other. The last thing you need to be doing is staring at your tachometer to see what the RPM is. You want to be looking out the window trying to figure out where you're going to put it down. So this way I can tell whether or not I'm exceeding that red line by listening for that very loud screeching tone. The next major mod that I made was to discard the original charging system on the left, which came out of a Briggs & Stratton riding lawnmower. This thing never worked properly for me. When it is working, it puts out maybe 12 or 13 amps, which is just barely enough to cover my normal load with all my equipment turned on. So there's really not enough excess power available there to recharge the battery from the start cycle. So people using this standard factory provided charging system have to be very careful not to try and start the engine too many times, or they'll run the battery down there and they'll be stuck somewhere. I got rid of that and went to a Denso 55 amp automotive alternator, which you see on the right. It was a major big project trying to fit this in and figure out how to drive that alternator. The first step in that project was with the help of a very talented machinist. We came up with a design for a pulley which will drive the alternator, and I had to have 20 of these made to get the production cost down and be able to afford the one that I need. They're CNC machined out of 6061 T6 aluminum alloy, and then hard coat anodized per mil spec for wear resistance. This is a beautiful, beautiful pulley, and you'll see how it mounts in a second. So here you see on the right, you can see the alternator tucked up there at the top of the screen, and the little belt that comes around the drive pulley, which mounts inside of the 6-ganged pulley that I mentioned earlier that's driven by the engine. And you can sort of see some of those 6 belts coming up from below, and you can see the top of the engine. That black assembly is the gear reduction drive. And the shaft that you see going from left to right is the tail rotor drive shaft. So this was all fairly difficult engineering challenge to get this all to fit just right. The other challenge was that under load, the transmission and the pulleys all torque about a 1/4 inch away from the alternator, so the whole frame bends a little bit. And so I needed some way for that alternator to be able to pivot, and a way to keep the spring or the tension on that belt the same no matter where the pulley was, whether it was moving away from the alternator or towards it under light load. The picture on the left shows the tensioner that I built. The spring that goes over that shaft is not shown, but that allows the alternator to be pulled inward as needed as the transmission flexes away from it under load. And the spring that goes over that extended shaft that you see sticking out then controls the belt tension. So that's the way I ended up dealing with that issue, and it works very well. And so after quite a few other mods that I made that I'm not showing yet, maybe I'll put those in later, After 4 years of construction, here's my helicycle in flight. And what you can see here, this is a fairly good picture showing how helicopters fly in forward flight. You'll notice that the rotor shaft, drive shaft, is tilted forward, and the rotor disc is at right angles to that shaft. And so if you think that of the thrust vector from the blades being perpendicular to that shaft, you can see that some of that thrust is used to overcome gravity, and some of it is used to pull the aircraft forward in forward flight. And so that's a very, kind of a basic description of how this works. And that's controlled by the cyclic in my right hand. The collective in my left hand controls basically how much power is going to the rotor system. And it's a little complicated to explain all that, but the more I pull up on the collective, the more power is going to the rotor, and the faster I'm going to go. And the cyclic in my right hand controls the orientation of the rotor. So if I want to go forward, backward, left, right, you do that with your right hand. And then last but not least, use the pedals to control the pitch of the tail rotor, and that controls your yaw. So that's helicopter aerodynamics boiled down into 20 seconds. The rest of the shots I'm going to show you were taken with a GoPro 2 camera mounted on a headband. Here you see me departing from my local airport, which is called South County Airport, or E16. And you can see, especially if you look at my little blurb on the instrument panel, you can see that I'm climbing out at about 70 miles an hour, and my rate of climb is right at 1,000 feet per minute, which is fairly leisurely climb. You can see, if you saw the layout of the airport, you'd see that where that little airplane is, that's not very far from the end of the runway where I lifted off. So I'm climbing at a pretty good rate. I'm already, let's see, it looks like, I think I'm at 500 feet, as near as I can tell. And by the time I get down to that other cross taxiway, I'll be up to pattern altitude. Here's a shot taken from outside the helicopter. I mounted a boom to the frame, stuck it out the left side, put the camera on it, set it up to take pictures every 2 seconds, and off I went. And this one's been rotated around to make the terrain horizon level. And so you can see that the helicopter is turning, it's making a left turn, and I'm turning from my downwind leg to base and getting ready to land on the runway, which is off to the left side of the frame. And the freeway that you see going across the nose there is Highway 101, which goes north to south through the San Francisco Bay Area. E16 is at the south end of the bay. Off to the west are lots of pretty rolling hills. This is a different location, still on the left side of the helicopter, but a different mount. The hills way in the background there are the coastal range. On the other side of those hills is Watsonville, and then beyond that is the Pacific Ocean and Monterey Bay. So one of the things I'm going to do soon is I'm going to fly directly over those hills, just in this direction I'm flying right now. I'll have to climb up from field altitude of about 200 feet up to about 3,500 to 4,000 feet to get over those mountains. and then descend back down, land in Watsonville, refuel, and then head over to Monterey Bay. So that'll be a nice little flight for me. Here's another shot just flying around the same area west of the airport, and this is the town of Gilroy. Here's one of my favorites. This is at the Miller Ranch during the 2013 Central Sierra helicopter meet. This is one of the two meadows in the ranch, and I really like just hover taxiing around in this meadow and watching the rotor wash this tall grass around. I think this is really a pretty picture. I like this one. And I think this might be the last one. This is also from the Miller Ranch at the 2013 Central Sierra helicopter meet. Here I'm flying downwind, left downwind for landing at the Miller Ranch. The rim fire swept through this entire area and wiped out, as of yesterday, 401 square miles. So almost everything you see in this picture is now destroyed, as far as we know. Hopefully the fire skipped over patches and left something up here, but it's not going to look like this anymore. It'll be a long time before it looks this green. So that's the end for now. I have several videos on YouTube, which should be in the same area. If they're not, you can search for them by using N750 Golf, or searching Helicycles, or by my name, Juan Rivera. And I have a tremendous amount of information, my builder logs, and all sorts of stuff at my website at www.juanr.com. So I hope you enjoyed this. Thanks for watching.